Magnetic field at a point on the axis of circular coil. Consider a circular coil of radius r is in YZ plane, perpendicular to plane of paper. What I have considered, this is a ring, circular ring, current carrying ring. This lies in YZ plane and its axis is along x-axis, perpendicular to plane of this board or plane of paper. At distance x, I have taken one point P. This is point P at distance x, and radius of this circular coil is R. Current I is flowing like that. See, one thing. Suppose this is circular coil. I have taken circular coil perpendicular to this plane. And this is y-axis. Y-axis, this is z-axis. And this will be the x-axis. The coil lies in YZ plane and point P lies on the axis of this coil, and that is, you can say, along the x-axis. So center of this you can suppose as origin. So this will be the origin for this three-dimensional figure. Current I is flowing like that. Current I is flowing. Suppose we want to find the magnetic field intensity at distance x on the axis of this. Point P considered, we want to find the magnetic field intensity on the axis due to this current circular coil. Consider an element. Let's suppose point A, I have considered an element dl. dl I have taken. Consider an element dl at top A of this coil. This current element ideal, see here, I have taken this current element here. A small current element I have taken. So this ideal lies in the plane of circular coil. So that will be the perpendicular to plane of board. So this ideal current element will be right angles to plane of board. And when we are joining the point by this current element, this I have supposed vector r. So see here, that is very important. If suppose this is the coil and this point P lies here on the axis, so this will be the radius r. So see here, you can see this current element dl, this will be perpendicular to board and this r lies inside the on the plane of the board. So angle between this r and current element, that will be 90 degree. You can see here, this angle will be 90 degree. See here, this is current element and this is vector r. So if you are seeing this angle in three dimensionally, actually in figure you cannot see, in three dimensionally you can see here this angle is 90 degree. So if you are applying Biot-Savart law, so this angle will becomes 90 degree. Angle between current element ideal and r. So see, magnetic field due to this current element at point P. So what happened? dB is equal to what? Mu naught upon 4 pi, that is ideal cross r upon, if you are taking this unit vector, so here it happens r square, or you can say what will be the magnitude. So this will be the mu naught upon 4 pi idl sine theta. So here this is right angle between r and dl, angle is 90 degree. So this will be sine 90 upon r square. Here what will be the direction? So see here, cross product idl, this dB will perpendicular to both dl and r. So I have shown here, suppose this will be the ring, this is vector r, one plane, this is one plane, this is another perpendicular to this. So this will be the direction of magnetic field. it will be perpendicular to both, perpendicular to R and perpendicular to DL. DL cross R, cross product. If you are rotating a vector DL to R, what happen? This will give the direction up. If we screw rotating from first vector to another vector, in the direction in which screw it was, that will be the direction of A cross B, mean DB, and DB is perpendicular to both ideal and R, a plane containing vector ideal and R. So here you can see this is ideal and this is R, so this will be the perpendicular to both. This will be the direction of DB. So see here in figure I will show, so this will be the direction of DB. If I am considering, if I am considering this is along x-axis, this angle, suppose between R and this position vector is smaller. If this angle is theta, what happen? This will becomes 90 minus theta. So this angle becomes theta. So this again becomes 90 minus theta because it is perpendicular to this angle becomes theta. So you can see here this dB makes angle with x-axis, that is theta. So see here, if you are resolving the components, so what happen? The component along x-axis or along the axis of coil, that is dB cos theta, and perpendicular to this, that is dB sin theta. Very important. What will be the magnitude of dB? Magnitude of dB will be mu naught I dl upon r square, and directed कैसा होगा? Perpendicular to I dl and vector r. ठीक है, that I have shown in figure. Magnetic field by Biot-Savart law, dB is equal to mu naught upon 4 pi I dl up sin 91 I dl upon r square, and the directed perpendicular to r and perpendicular to ideal element that we have shown here. This will be the direction of dB. It will makes, if this angle is theta, it will makes theta angle with the axis of coil. Consider another element. Suppose this point I have taken A, diametrically opposite. I have taken another element, same length dl. What happened? If another element dl I have taken just opposite, diametrically opposite to first point at the top which I have taken, so this will at the bottom. What happened? If you are joining this, direction of magnetic field, suppose the value of magnetic field is, suppose here dB dash. What will be the value of dB dash? So same thing you can see here, this distance r, the magnitude will be same because all points of this circular coil from P, each and every point, that will be the same distance. You can see here all are at equal distance. If you are taking that point, this is also, if you are downward, they all have same magnitude. The value of R will be same for all current element. The value R is same. So if you if you apply the Biot-Savart law, what happen? The magnetic field due to current element, field due to current element at here A I have taken at top, diametrically opposite I have taken another point B. At point B, diametrically opposite to A, opposite to A. So this, suppose this is dB dash. So dB dash is equal to what? Magnitude of dB dash This will mu naught upon 4 pi I dl sine 90 upon magnitude will be same, and direction I have shown here perpendicular to this and dl, so this will be downward. So here you can see the magnitude of both. Suppose this is I have taken as magnitude of these vectors. The magnitude of dB and dB dash, this will be the same. Both mu naught upon 4 pi I dl upon r square, same. Mu naught upon 4 pi I dl upon r square. Here magnitude is same. If you are taking the components of dB dash also, to what happen? This have the components, this again, this will make sine angle theta, same angle theta. So what happen? There is dB dash cos theta and dB dash sin theta. So see here, this dB sin theta and dB dash sin theta, both will opposite, they will cancel each other. Only dB cos theta, because magnitude is same, so dB dash cos theta is also written as dB cos theta. Here also magnitude is same, magnitude of dB and dB dash is same. So this dB sin theta will cancel each other. Only dB cos theta along the axis, that will be the resulting magnetic field intensity or induction due to this diametrically current opposite element. Here we can write, taking components of dB and dB dash, what happen? dB sin theta, perpendicular component, perpendicular to axis, dB sin theta, components cancel each other, only dB cos theta, कौन सा कंपोनेंट बेटा? dB cos theta, only dB cos theta along axis will added for resultant intensity. For resultant intensity, what we have seen, only dB cos theta component will be, which is along x-axis or along the axis of coil, will be added. So see here, if we have taken many components, suppose here I have taken point A dash, diametrically opposite I have taken any points here, B dash, again we will find dB and dB dash. So dB sin theta will cancel, only dB cos theta component will be along the axis of coil and just outward for this anti-clockwise. If suppose reverse direction I have taken, so this will be the inward. So only dB cos theta components will be for all current element of circular coil. So what will be the resultant intensity? If we will go for the resultant intensity of magnetic field, intensity of magnetic field induction, what will be the resultant? Magnetic field induction due to circular coil at point P. So that will be summation of all components dB cos theta. So summation we can write as integration of dB cos theta. Okay. for whole coil, whole circular coil, for circumference of whole coil, summation of dB cos theta. What is dB here? So dB is what? Mu naught upon 4 pi, that is I dl upon r square, and cos theta. If you see here, so cos theta is equal to base upon hypotenuse. So cos theta base is r. Cos theta will be r upon hypotenuse, that is r. So this will be the mu naught I dl r cubed. This we can take out I r upon 4 pi r cube. So see here, this will be the integration of dl for whole coil. What will be the total current element, element dl for the whole coil? So this will equal to how much? 4 pi r cube. So for whole coil, summation of all element, so that will be the circumference. So circumference of this will be 2 pi r. If you are cancelling this, so this will be mu naught I r square upon 4. See here, what is the relation between r and x? By Pythagoras theorem, what we will say? R square is equal to r square plus x square. So r is equal to r square plus x square power 3 by 2. So if you will see here, so in the place of r you will write r square plus x square power 3 by 2. So this will be the magnitude of magnetic field induction. B is equal to mu naught I r square upon this 2 2s are 4. So this will be the 2 r square plus x square power 3 by 2. And direction will be what? Along axis of coil. If we take anti-clockwise here, so this will be the outward. If you will reverse the direction, the direction will be inward. So this will be the magnetic field induction due to circular coil on the axis. If we have taken any point at distance x from the axis. Suppose I have taken as P point as center. So at center also you can calculate. If point P lies at center, what will be the magnetic field intensity at center? So this B is equal to, for center what happen? This x becomes 0. So for center what happen? Put x is equal to 0. Putting at x is equal to 0, that will be B mu naught I r square upon 2. X is equal to 0, so r square power 3 by 2. So that is r cube. That is mu naught I upon 2r. That will be the magnetic field intensity at center of coil.